WebAssign 11, question 3, part D. Once again, to figure out if this is oxidation reduction, we've got to assign oxidation states to each of the elements in the compounds that we find in the equation. Between silicon and chlorine, the more electronegative atom is the chlorine, so it would take its normal charge based on position in the periodic table. Silicon's oxidation state is initially unknown, but with a little bit of math we'll be able to find it. One atom of silicon times an unknown oxidation state of X, when added together with 4 atoms of chlorine, whose oxidation state is known to be -1, should add up to the overall charge. Notice that in this compound it's 0 overall, so we'll just put in a 0. We'll add 4 to both sides, and we find that X equals 4. Now on to magnesium. If it's neutral and alone, its oxidation state is 0 by definition. Same thing with solid silicon. Neutral and alone, oxidation state of 0. Magnesium chloride. Here's a pretty straightforward one. We have an ionic compound. The oxidation states will simply be equal to the charges. Magnesium's a group 2 element, and chlorine's a group 17. So it's a +2 -1, and you can see how 2 atoms of chlorine cancels out with 1 atom of magnesium to give you a neutral compound overall. Let's record what we just figured out. +4 for silicon, -1 for the chlorine in silicon tetrachloride, 0 for the neutral magnesium, +2 for magnesium within magnesium chloride, -1 for chlorine there, and another 0. What changed? Well, let's look at silicon first. On the left side of the equation, its oxidation state is +4. On the right side of the equation, its oxidation state is 0. That means its charge went down, and the only way for that to happen is if it gained electrons. I'll use an E- to represent electrons. Chlorine is -1 on the left side of the equation, and also -1 on the right side of the equation. Chlorine was not oxidized nor reduced, but magnesium was. Magnesium started out with a 0 oxidation state, and it went up to a +2. So whereas silicon's oxidation state went down, magnesium's went up. The only way for an oxidation state to go up is if the element loses electrons, and losing electrons is oxidation. So to answer the first question, which is a pretty straightforward one, yeah, we've got changes in oxidation states. So yes, this is an oxidation reduction reaction. The oxidizing agent is the compound that contains the element that was reduced. I'll repeat that. The oxidizing agent is the compound that contains the element that was reduced. And I should specify, it's the compound on the reactant side. So maybe we should record this. The element reduced was the one whose charge was reduced, and that is silicon. The element oxidized was the element whose charge went up, and in this case that is magnesium. So when identifying the oxidizing agent, we look on the reactant side and find the compound that contains the element reduced, SiCl4, write it down and you're done. The reducing agent is the compound that contains the element that was oxidized. Here, on the left side of the equation, the only the only place you find magnesium is neutral magnesium that's alone. So in this case, the reducing agent is also simply that element's formula, Mg. And then lastly, the last two questions. Actually, I think you have to answer these last two in order to answer the first two. It's kind of funny. They should switch the order of that. The substance or element being oxidized, we had said up above here, was magnesium. And the substance or element that was being reduced is silicon.